Hello everyone, the problem that we're looking at today is the USACO 2019 January contest gold problem 2 of sleepy cow sorting. You can pause the video first and look at the quite lengthy problem statement yourself first. Okay, so basically you have n cows, you just have a sequence of numbers and now you're trying to sort these numbers so they're in the right order. So for this you want to sort it into 1, 2, 3, 4. And however, each time you can only move the number at the very front. You can move it to any other spot in the sequence, but only the number at the front is movable. After you move 4 away, it's going to be, say, look like this. Now you can move 3. And now you're trying to output the minimum sequence, the minimum number of moves required to move the cows and the sequence of moves that you need to move it. So for example, for this, you need at least 3 moves, and the 3 moves are moving the first cow back 2, second cow back 2, and then the third cow back 3. So first cow back 2 right here, right? Between 2 and 4. Move 2 back 2, so it's going to be between 1 and 4, and then you move the 4 back 3, so it's going to get past all of 1, 2, and 3, so it's going to be at the very end, and now you have the whole thing sorted. So you can pause the video once again and think about how to solve this problem yourself. Okay, so for gold, it's 2019 January, so not too hard. 2019 January of silver was a complete joke. I AK the whole contest, 1,000 points in like 30 minutes. So 2019 January gold is also kind of simple. Anyways, first of all, you have to play with a sample for a few times yourself. And if you're above bronze level, you should probably know this, then how to calculate the minimum number of moves needed. You probably won't know the sequence of moves if you're bronze level, but you know how to calculate the number of moves, because there's the exact same problem in bronze in which you just had to output the number of moves. And after playing with the samples, if you're over bronze level, you should notice that it's just the length of the maximum increasing suffix, largest increasing suffix of this sequence, because this can be easily proven. Cows in largest increasing suffix are already sorted, so you don't have to move any of them. You can just insert other cows between them. And if you don't move any of the cows that are not in the maximum increasing suffix, they either form inversion with some other cow or block some other cow that forms an inversion from us moving it. Either way, we need to move this cow away. So the minimum number of moves needed is just the length of the sequence minus the length of the largest increasing suffix. Now we just need some kind of a data structure that supports adding points and finding the number of points that's less than a certain value, so we know how much we can move it back by. And while BIT, binary index tree, we completely sufficient, I decided to use a variation of the segment tree called the weighted segment tree. So here's the overly complicated lengthy solution, while you can just simply use the BIT, which will be completely sufficient. And the code other than the BIT or segment tree in this case are very simple. You input the sequence. For each of them, you check whether it's in the maximum increasing suffix, insert it into the segment tree if it is, and then find the number of spots you need to move each cow back by. And we're done. Okay, so hopefully after this video, you know how to solve the 2019 January gold problem 2 of sleepy cow sorting. I think if you know your data structures, this should be a problem that's easier than the first one, cow poetry. Cow poetry is also kind of easy, but at least there's some DP counting and stuff. So hopefully this video helped. Thank you for watching, and I'll see you tomorrow. Okay, so for the grind report, not really even grinding anymore today. Okay, by the way, if you're new to the channel, this is the grind report part. So the problem review is completely done. You can go ahead and click out if you're just here for the problem. So for the grind report today, well, I solved the problem. Technically, if you guys even know what the XOR linear basis is. But anyways, I solved the problem involving the XOR linear basis, and it's just a template on Logu. And it took me a bunch of tries because I'm an idiot and I did not realize I need to put one long instead of just one. But well, anyways, yeah, I just solved the problem. And I also had a programming class today, and I learned the XOR linear basis, of course, and also an algorithm called digit sorting or whatever, in which is a ON sorting algorithm. Yeah. Okay, thank you for watching. I'll see you tomorrow.